Hi, are you struggling with quadratic sequences? Worry less because you're at the right place. So today I'll be doing quadratic sequences, deriving some formula that is important for you to derive your general terms and other stuff. So first things first, what is a quadratic sequence? This is a sequence of numbers where the second difference is constant. And what is important is that the second difference that you're looking at is between two consecutive numbers or two consecutive terms. So we have a general formula, quadratic sequence. Do you get any hint there? So it means that the equation is a quadratic, right? The quadratic, or is the polynomial of second order. So the general formula that we have is Tn is equals to an squared plus bn plus c. So let's try to substitute and see what we get if we don't know. So let's assume that we don't know a, b, and c, right? How would our terms look like, or what would our terms look like if we don't know a, b, and c? For the first term, we substitute n is equals to 1, right? And then we're left with a plus b plus c. A plus b plus c. Great. So, and then for the second term, what we're gonna have is that 2 squared, which is 4a, right? We're gonna have 4a plus 2n plus c. For the third one, it's going to be, please go check. For the third one, I think it's going to be 9a plus 3b plus c. And then for the last one, you have 16a plus 4b plus c. So these are the terms, assuming that we don't know a, b, and c, right? So let's derive some formula to help us derive the general term for a quadratic sequence. So if you take our T1, this is what we have here. This is T1, this is T2, this is T3, and this is T4. So we're taking them like that. We're taking the first difference, we're taking the second difference. Recall what is the definition of a quadratic sequence? It's a sequence that has a constant second difference. So here we're taking the first difference, right? And then the second difference. So let's now look at it. If you take the first difference, it's going to be 4a minus a is going to be 3a, 2b minus b is going to be plus b, and then c minus z is 0, right? And then let's look at this one. 9a minus 4b, that is 5a, 3b minus 2b, that is plus b, and then the c is left out. It's not left out, it's cancelled. C minus c, and then 6a minus 9a, what we get is 7a plus b again. The c's just cancel out. So what we can notice here is that 5a minus 3a is 2a, and then the b's cancel, and lastly what we're gonna have is 7a minus 2 and minus 5a, which is 2a, and then the b also cancel out. Okay, what can we see here? What can we deduce from this diagram that you just constructed? Is that the second difference is constant. What do I mean by that? So the second difference, the first one is 2a, the second one will be 2a. So as we continue, we're gonna get all 2a's. It's constant. What is this? This is the this is one of the properties. This is the main property of a quad sequence, right? Sequence. Great. So now these a plus b plus c, 3a plus b, and 2a are the formula that we are going to use to find a, b, and c. I hope I'm making sense. So if we have a constant difference, a second constant difference, we can find a. We take the a, we substitute it here, we're gonna find b, and then we have a and b. substituting them here, we're gonna get C. I just hope that you see what I'm talking about. So, and also there's also an important remark is that the first difference, they form an arithmetic sequence. The question is why? Look at this. What is the property of an arithmetic sequence? The property is that it has a first difference that is constant. So if we just assume this is the series, or this is the sequence rather, this is the first difference of the sequence, and it's constant. Therefore, it's an arithmetic sequence. Good. So next, we'll be looking at an example on how to find the a, b, and c in this equation, an squared plus bn plus c, because this is the general term. This is the the nth term of the general equation. Great. So I just hope you enjoyed this video. So please like, share, and subscribe the video. I'll see you on the next one. Cheers.